morning, everyone, and welcome. My name is Deon Katz, head of Anchor Private Capital, and I'm joining you from Anchor's head offices in Johannesburg. I'll be hosting this morning's latest in our series of webinars, where we'll be chatting about artificial intelligence in our presentation entitled AI, the story of AI and two brilliant Englishmen. I'm thrilled to be joined today by my colleague and today's presenter, David Gibb. David is an industry stalwart and leading investment professional with 30 years of experience in investment management. He manages our Anchor Worldwide Flexible Fund and the Anchor Global Technology Fund. David is an inspirational source of knowledge and thought leadership within our business. David, thank you for compiling what promises to be a fascinating and thought-provoking presentation. For the Anchor Group, as one of South Africa's largest independent investment managers, with over 110 billion rand in assets under management and advice, we understand the significant responsibility that comes with being custodians of your wealth. We have a culture which demands high performance, excellent client service, and thought leadership. We acknowledge that it is imperative to stay constantly ahead of the curve in an exponentially changing world. We strive to direct our efforts and resources to ensure the best outcomes for clients, and this means pouring hours of time into researching global markets and investment trends. This morning, we'll be focusing on what is without doubt one of the most talked about and hotly debated topics in the world today. Artificial intelligence, or AI, has already driven considerable change and innovation through industry and society, and promises to do so for many years to come. Whilst many experts have very different thoughts on the future impact of AI, almost everyone agrees that its applications will have a monumental and perhaps existential effect on all spheres of life in the decades to come. Stephen Hawking, the late British physicist, philosopher, and Nobel laureate, said that AI is likely to either be the best or the worst thing to happen to humanity. Sam Altman, the founder and CEO of OpenAI, who are responsible for developing ChatGPT, suggests that AI will probably, most likely, lead to the end of the world. But in the meantime, there'll be great companies. Well, thank you for that, Sam. At least we have the promise of some decent returns before we're all obliterated. Mark Andreessen, founder of the renowned private equity firm Andreessen Horowitz, recently wrote, "The era of artificial intelligence is here, and boy, are people freaking out." He goes on to say that AI will not destroy the world, and in fact, may save it. Before I hand over to David, please feel free to send us your questions anytime during this webinar. You'll see a question tab at the bottom of your screen, and we'll take some time at the end of the presentation to get to some of these questions. Thank you very much, and over to you, David.
Thanks, Deon, and good morning, everyone. So we start our story of AI with Alan Turing. Let me just get my... Alan Turing, who was born in London, and he went to university in Cambridge, and he graduated with a mathematics degree. And Alan Turing is regarded as the father of theoretical computer science and artificial intelligence. And he's most famous really for breaking the Enigma codes, the German codes that allowed Britain to win certain battles in World War II. But Alan Turing wrote a paper in 1950, which is now known as a famous paper, and it was called Computing, Machinery and Intelligence, right? So in October of 1950, I've been through the paper, and the essence of the paper was that if we can design a machine that displays the intelligence equivalent of a human being, then it doesn't matter how it works, we should then call it intelligent. And that was known then as the imitation game, where a machine can imitate the intelligence of a human. But later it became known as the Turing test. Can a machine display the intelligence of a human? And this goes back all the way back to 1950. So how do you go about this? I mean, how do you make an intelligent machine? the first way you can do it, and this is what we did when computers first came out, was you can program it. And frankly, most of what we use on our computers is just programmed. The other approach, which is something that's more recent, but initial moves were made in this direction decades ago, is to teach the machine to learn like a brain. And this is not something you can program, but you teach the machine to learn like a brain. And I think if there's one thing I want you to remember from this talk, is this is where we are now with modern AI. We've taught the computer to learn like a brain. And that's why we're having these incredible advances in recent years. So if you go back and you look at the history of AI, and we go back to Alan Turing, I mean, he wrote a chess-playing program in 1948. But if we start at our, 1950, it's really been a story of boom and bust. Enormous excitement, and then basically AI winters. So it's an unusual field. People spoke about the first AI winter in 1974 to 1980. The second AI winter followed actually soon thereafter. But there are a couple of highlights along the way. And I just want to take us on a little journey. So we're going to talk a little bit about the history of AI, where we get to this place. And then we'll talk about the future. I think, the important thing for me is I want you to try and understand where we've come from, and it'll help us predict where we're going to go. But before we got to this first AI winter, most people were trying to program computers. There wasn't much emphasis on trying to, replicate how the brain works. But there was an interesting development in 1958 where a young guy, Frank Rosenblatt, and he worked for Cornell Aeronautical Labs in New York, and he was funded by the US Navy. He came up with this machine called a perceptron. And this perceptron, what it did was it kind of displayed an original idea. It was able to distinguish on these cards, on these punch cards, whether the cards were punched either on the left or the right. It was able to establish that, and it was considered at the time to be almost replicating how the brain worked, as in a simple way. So it was a simple artificial neural network in that it wasn't pre-programmed to work this way. It could actually come up with its own idea. And he did this using an IBM 704 machine, which weighed 9 tons, right? So it was not the sort of thing that was easily accessible to a lot of people. The problem with the perceptron was that it was quite limited, and it wasn't a very well-designed neural network. And so after this study, about 10 years later, people wrote a book just writing about the limitations of a perceptron. And this kind of started the first of the AI winters in 1970. And if you look at a simple artificial neural network, this is more complicated than the perceptron, is you have different layers. Here we've got a 4-layer neural network. It's trying to replicate how the brain works. You have neurons and you have synapses, and you have inputs coming in on the left, and you have hidden layers, and then you have an output. And we'll come back to this. And there are lots of diagrams you can find on the internet if you want to understand how these neural networks work. If you have more than one hidden layer, it's known as a deep learning neural network. So a basic one just has one hidden layer, but more than 2 or more than 1, then we're talking about a deep learning neural network. But before we come back to that, soon after the second AI winter, which ended in the 1980s, Garry Kasparov, the chess champion at the time, he agreed to play chess against Deep Blue, which was IBM's special computer that was designed for chess. And it was, the idea was he would play a 6-game tournament and see who would win. And it was an interesting, this was an important development for AI, very useful to test AI against a board game, chess or any other kind of board game. And it would obviously always then get, you're playing against the world champion, and it would certainly get the news. So Garry Kasparov, when they got to the 6th game, they were tied 1 game all, and they'd had 3 draws. And for the first time in his career, Garry Kasparov conceded defeat in the last game. And this was, this really was big news. And Garry Kasparov is still regarded as the greatest chess player in history. But the thing about this Deep Blue machine is that it was programmed to play chess. It wasn't like a neural network that taught itself how to play it. It was programmed. So this was almost the limit that you could get to on intelligence, where you were actually programming the machine. So there was a lot more to come after this. So during that AI winter in the 1970s, a chap, and this is now our second brilliant Englishman, Geoffrey Hinton, also born in London, also went to Cambridge, a very interesting guy. He changed his subjects a lot at university, but he eventually qualified with a degree in experimental psychology. So clearly very interested in the brain. And he decided to go into this field of artificial neural networks. And he was inspired by some of the work that was done by Frank Rosenblatt, but more specifically, he took the line that Turing had taken. Turing had also been fascinated with the brain, and he felt that that we need to try and design a machine that can't exactly replicate the brain, but that is inspired by the brain. So he moved to Canada, and he went to work at the Canadian Institute for Advanced Research. And interestingly enough, a lot of people came to work with him, and he set up a special neural networks lab there. And Canada, in some ways, has been the leader in artificial neural networks. And Geoffrey Hinton is probably now regarded as the main godfather of this field. When he was in Canada, he had a PhD student who worked for him, and they decided to enter a competition, right? A simple competition, well, quite difficult to do, but it was called the ImageNet Visual Recognition Challenge. It was a large-scale visual recognition challenge, and it had started in 2010, so this was the 3rd year. And they decided to enter the competition. The PhD student was Alex Krzyzewski. He was born in Ukraine and had settled in Canada. And his mentor, obviously, then was Geoffrey Hinton. And he also had another young student working with him, Ilya Sitskova, who is now the researcher in charge of OpenAI. And Alex decided to design his own neural network. It was known as a convolutional neural network. We won't go into the details here. And that was an unusual move. And what he also used was he included 2 NVIDIA GPUs to speed up this process. Now, the whole thing about this competition was you had over 1 million images, and you needed to identify images and classify them. It was a very difficult task, very memory intensive. And that's why they decided to use 2 GPUs. And we'll come back to what GPUs are. And what happened in the competition was when the results came out, AlexNet thrashed the competition, right? The error rate of recognizing the different images was much lower than the competitors. So their error rate was only 16.4%. Now, this was a revelation in the field at that time. And in fact, Google was so amazed at their results that they hired all three people, right? So they hired Alex Krzyzewski, Ilya Sutskever, and Jeffrey Hinton. They all went to work at Google. They had been working on neural networks for some time up until then, but they were clearly very impressed with what they had seen. But before we talk about anything else on neural networks, we need to understand the link that neural networks have had with NVIDIA. So, you know, Alex Krzyzewski had used two of these GPUs that had come from NVIDIA. NVIDIA is a very interesting company. It was started by Jensen Huang, a Taiwanese guy who'd moved to America, and two co-founders. It had started in 1990, and it started out as a graphics processing unit business, right? So when you played computer games, what the GPU did was it would render images on your screen. So if we look at a GPU on the left-hand side here, a graphics processing unit, it's very good at dealing with a lot of it needs a lot of memory, and it basically runs in parallel. So it does parallel processing, and it can deal with a lot of content, right? So it's very different to a central processing unit, which is what we have on our computers primarily, which is really built for speed. So this is all about low latency, having a Ferrari that performs functions serially, whereas a GPU is like having a big truck, and it can arrive with lots of data. And this is the kind of ideal thing that you need for neural networks. And we'll come to that in a second. So I think this is another one of my slides that I'd like you to just remember when we talk about deep learning, right? So deep learning, as I've said, is about having a neural network that has more than one hidden layer. Now, there are two parts to deep learning. The first part is training, right? So you arrive with the neural network, and you decide that we're going to put a data set through it, whether it's the public internet or a data set that Anchor Capital might have, and we need to train the data. So we put all the data through our untrained network, neural network. Typically, you want this to be done within a month, right? So a large data set like GPT-3, which was the predecessor to GPT-4, that it took, or it depends on how much memory power that you have, but it can take up to a month to train all the data on the internet, all the public data on the internet. So once you've trained all of this, and to do this, you need GPUs, right? There's so much memory that you need. You know, for GPT-3, it was about 175 billion parameters that you needed to deal with. GPT-4 was 1,000 times bigger than that. So the key thing here is you need lots of compute power, and training. It's almost like going to school or going to university and getting an education, right? So you're training your model. And the NVIDIA GPUs have got about an 80% market share in this segment. Once you've trained your model, then the users like ourselves can use the trained model. We can go onto a chat GPT, and we perform something called, or we're involved in something called inference, right? So we will input a request on chat GPT. I don't know how many of you have downloaded it onto your phones, but you will type in a request, you know, maybe could you write a poem for me or whatever? And what it does then is it goes through the trained model, and it'll come up with an answer for you. And this is called inference. So this is applying the knowledge that you've learned at university or at school in your job. So it's a different, the computing requirements are a lot lower here, and typically it's dominated. This will be done by CPUs. It's all about speed, right? So you want a quick response. whereas this is about dealing with enormous amounts of data. So you need a lot of memory. So this is GPU driven on the left, and this is CPU driven on the right. And this is one of the reasons why the NVIDIA share price has performed so strongly in the last couple of months. This is Jensen Huang showing off his H100 GPU chip, right? So this is the Hopper 100. It came out last year. Now, they've been working closely with the AI community since about 2012. So it was perfectly designed for deep learning. And frankly, they're probably, some of the experts say, maybe a couple of years, maybe 2 years ahead of the competition. So that'll be AMD or maybe even slightly longer with Intel. And that's why the share price has now gone over $1 trillion. So just a little recap then. So where have we come in artificial intelligence? You know, we started maybe in the 50s. There was a lot of excitement, boom and bust periods. And then people started using algorithms. So machine learning became a subset of artificial intelligence. And this you see when you're watching Netflix, where they can predict what you may want to watch, what you see in social media, with predictive text when you're typing up a text message. But none of these things used neural networks, and that's where we are now. In deep learning, pretty much starting with AlexNet's win in that challenge of neural networks. So now we are trying to learn like the brain learns, whereas before this was largely partly programmed and using algorithms. So I think the last time I want to just touch on board games. This was an important development. In 2016, Lee Sedol, who was the Go champion, which is an ancient Chinese board game, he played against AlphaGo. Now, AlphaGo is a machine designed by DeepMind, which is a UK-based business. Alphabet had bought this business in 2014. It was founded by this chap called Demis Hassabis. And Demis Hassabis was a child prodigy. He started playing chess when he was 4. He played for the junior England team, really a fantastic chess player. Also went to Cambridge, and he started a business called DeepMind. And they also worked on board games. And this was an important development because in this case, unlike Deep Blue, they played against Lee Sedol using two artificial neural networks, and they used a decision-making tree. And they beat Lee Sedol, and it was just an amazing development. A very difficult, a lot more complex than chess. Once you've made your first 2 moves in chess, there are only a couple of hundred moves that you can make after that. Whereas once you've made your 2 opening moves in Go, it's something like 130,000 moves you can make thereafter. So a lot more complex. So I think one of the things I think we need to remember here is that we've been able to rely on Moore's law for many decades. And you can see here with Moore's law, the basic idea is that computing power doubles every 2 years, right? So once we moved into this modern era of AI with AlexNet, and you can see this image classification, the blue bubble here. Once we moved into this, we needed more computing power. So Moore's law couldn't keep up with the demands of this modern AI era. And that's why we've needed GPUs to be used a lot more. We need to accelerate the process. And you can see the requirements for compute, for training, are really just too much for the CPU market. And this is another reason why, this was almost the Intel era here in this lower line. And now we've moved into another era where we need GPUs. And so AMD and Intel are all scrambling to try and stay in touch with NVIDIA in this market. Now, before we talk about the future of AI and kind of where we are now, the last company I just want to touch on is OpenAI. Now, OpenAI started in about 2015 at a conference at the end of 2015, I think in Montreal. Elon Musk and Sam Altman and a group of about 10 researchers, they launched OpenAI with great, very idealistic plans for the world. The idea was that it was going to be a non-profit business, and really it was all about having a positive human impact. So this was an exciting development. Obviously, Google was already working on this. So there was competition out there. But I think what we soon realized with OpenAI and with all these other AI businesses is that they need compute power, right? We've spoken about all the memory requirements for training. And so they needed to partner with someone. DeepMind had already partnered with Alphabet at this time. So Sam Altman bumped into Satya Nadella at one of those Sun Valley conferences, which I think they've just had recently in the US and Idaho. And Satya Nadella, to his credit, with some resistance from Bill Gates and their own research team, decided to invest $1 billion and basically build a little supercomputer for OpenAI to start training its data. So that started, and then subsequent to that, they've invested another $12 billion, and they now own about 49% of OpenAI. And I think what's interesting about when you compare Alphabet and Microsoft, Microsoft traditionally has not been strong in the consumer markets, right? They're very much an enterprise business, whereas Google has been very strong dealing with consumers, with search and whatever. So I think what they've wanted to do, and you can sense it with Microsoft, is they're desperate to try and gain share in the consumer market. Now, before we get to that, one thing they did do last year was they launched this Copilot, right, which helps you program, which helps coders, write code, right? So roughly, they say on this slide, this is Scott Guthrie, who runs their cloud business. About 46% of new code is now written by AI. So it makes developers a lot more productive. So they came out with this last year. Microsoft, they've been very aggressive with their product launches. This is their chief technology officer, who is almost like a child with a toy with the OpenAI tools. And he is just very excited about all the products that they can launch. And you can see, I think the other day, they're now going to start charging for some of these AI products. They'll be charging $30 a month for their Windows 365 sort of clients. So there is enormous excitement within Microsoft. Google, in a way, has been quite cautious in releasing new products. In some ways, they've focused on a lot of research and they have led the industry, but Microsoft, in a way, has stolen a march on them, and now Alphabet has to catch up. So where are we now in AI and where are we likely to go? So I think what we've seen with AlexNet in 2012 is that started this era of recognition. I've got a picture of a cat here. A lot of the challenges then were distinguishing between a cat and a dog. So you see a lot of cat pictures when you look at this sort of recognition era. And it was also recognizing language. So it wasn't just images. So it was understanding things. So we've really just moved out of this era now, and we're into the era of generation. And I think what's interesting about ChatGPT, which is OpenAI's inference engine, right? So we can just type in a request and inference can be done on their large language model, which at the moment is GPT-4. And it's really captured the public's imagination. Joe Public can go out there and type a request into his computer. It's just very accessible. It doesn't require any particular understanding of how a computer works. And I think that's what makes it so exciting, is that it's drawn the consumer in to generative AI. And I think, hats off to OpenAI for doing that. And I think Microsoft can feed off that. So what comes next? Most of that data is public data. It's just pulled off the internet. What we're seeing now is some specialization by industry, right? So Google is launching MedPalm 2, which is a specialist product for the medical industry. There's also a lot of demand from legal services providers like LexisNexis. They're going to be providing generative AI products for their clients. We'll see it in education. We'll see it in the finance industry. So we're going to have these specialist large language models developed across a range of industries. And basically, they will be smart assistants for their clients. So instead of relying on a junior lawyer to tell you, about the case history in particular fields, you can just get that request from the LexisNexis generative AI product. So that's, I think, the first thing is this big shift now to specialist products. The next thing is building generative AI apps for companies, right? So custom models for businesses. Now, in this last week's Economist, there's a story about Sanofi, the French pharmaceutical company, and they've launched, the last month, they launched their equivalent of ChatGPT. It's called Plai. I'm not sure how you pronounce it in French. It's PLAI. And that is an app that, the CEO, Paul Hudson, has it on his iPhone, and it draws on about over 1 billion data points from Sanofi's business. And it gives him a sort of snackable data source to tell him about what's happening in his supply chain, what's happening to sales. So it's almost like employing your own young Cambridge graduate as a sort of smart agent. And this is the kind of thing that I think we can expect across all businesses going forward, right? So Anchor will have its own, it'll have a series of generative AI apps. Obviously, they need to be partitioned too. It's not like we can have everyone seeing all the payroll data at Anchor Capital. So I think relative, based on your function in the business, there will be an app that you can draw on. And the other thing is to adapt them to smaller devices so that we can do these things on the smartphone. So you will train all the data centrally on big computers, but then the inference can be done remotely on smaller devices. I think that's the important thing, because we need to make it accessible and we need to make it cheaper, because at the moment it's very expensive to do all of this. So that's where we are now. Now, in a recent interview, Demis Hassabis, the deep mind, well, he's now taken over the merging of Google. They had two AI businesses, Google Brain, and they had DeepMind. Now they've merged those, and he's in charge of that. And he really talks about what comes next. And we hear this from Ian Buck at NVIDIA too. The next part is reasoning. So these chatbots, this is kind of the first iteration of this sort of modern AI. The next thing will be reasoning, planning, problem solving, and that'll make the AI a lot more reliable. There'll be a lot less hallucination where they just make up stuff. They're not so good at dealing with chains of reasoning at the moment. So it'll make it a much more important product in a business, right? And then I think the idea is that we'll develop tools. So we'll break up, you might go into a central ChatGPT, a sort of a word login area. And based on your requests, you might have your requests fed to a range of different large language models based on specialization. And so there'll be different tools that you use so that the whole process works more efficiently and is more accurate. And basically, I think what happens with this is it just makes it easier for us to use computers, right? Be more like switching on the plug on the wall for electricity. To now, up to now, to work in computers, you had to understand the languages, and it's a lot more complex. Now you'll just work with English, right? You won't have to know how to code in Python or whatever. So very important in making computers much more accessible. What comes after that? Obviously, the end game is artificial general intelligence, right? Or general AI. Some people also refer to it as godlike AI. And this is where the AI system doesn't need supervision. It can transform the world around us. It can design its own drugs without any input from humans. So in this sense, it becomes a universal assistant for any of us that, it basically allows us to become a hell of a lot smarter by having not just a basic Cambridge graduate, but a PhD in so many areas as our personal assistant. So this is the end game. Now, before we get there, we need to make a lot of progress in making AI safer for humans. So this was just a chart that was drawn by a chap called Ian Hogarth, who wrote a piece in the FT in April. And he spoke about the progress in AI that we've made, the progress in capabilities, and that's the blue sort of curve here. But then he draws the red curve, which is process on alignment. And alignment is sort of AI speak for aligning with human values. Is it safe for humans? Is it safe for the planet? And frankly, we haven't made much progress here. And this is why people, the Center for AI Safety came out with this statement, I think it was last month, that was signed by luminaries in the industry. I think Jeffrey Hinton signed it, Sam Altman signed it, Demis Hassabis signed it, is that basically, in a way, it's a call for help, that there's now the genie is out of the bottle on AI, and it's gone from academia into business, and we actually need to get on top of this stuff. So I think we will, it obviously scares a lot of people. And if you look at the godfathers of AI, Jeffrey Hinton here in the middle, all three of these guys, they won the Alan Turing Award, and I think in 2019, which is like the Nobel Prize for computing, for their work on AI. These two, Jeffrey Hinton and Yoshua Bengio, who's still an academic in Canada, they're very worried about what's going to happen in AI, right? So Jeffrey Hinton has resigned from Alphabet, so he feels that he needs to have a free voice to speak about the perils of AI. Jan LeCun, he works at Facebook. He's less worried about it. But I think we want to just remember one thing. When the nuclear bomb was developed to end the Second World War, a lot of those scientists felt that the nuclear bomb could completely destroy the planet. And so the experts in the field often think more about catastrophes. And so, maybe we will introduce a lot more controls like we've done with nuclear weapons to control the bad side of AI. But, obviously we're going to be reading a lot more about this. So what are the implications here then? So I think if we look back, technology typically comes in clusters. If you go back over the centuries, these are novel, important technologies. When the telescope was first invented, we're now in the digital era, right? Which started with the PC, and then we went to the internet, and now we are in this AI era. And what typically happens is these technologies, these clusters, so it's one novel technology followed by a range of other ones based on that original technology. They sweep across the economy. They change society, they change jobs, new jobs are created, old jobs are, become redundant. So this is what we can expect here. So what about generative AI? What sort of impact will it have? Because it's largely based on data, right? It's all about knowledge. So we can go back through the public data set on the internet and we can pull out all sorts of knowledge. So it will certainly have a bigger impact on knowledge work, on decision-making, collaboration, which previously, you couldn't really automate. So that was just a statement from McKinsey. They put out a report on this last month on generative AI. And if we go back to March this year, Goldman Sachs felt that this is just a slide where they are looking at what impact AI could have on employment in the US. And they go through the different sectors that are most affected. Look, on the right-hand side, I mean, if you're a gardener, you're okay, right? Not much impact here. But if you work in the legal profession, with LexisNexis offering you a generative AI product, if you're in office and admin support, potentially a big impact too. So I think their sense is of all employment in the US, roughly 25% of people will be affected. Either it's going to undermine your role, or you'll use it to augment the function that you're performing. But it will certainly have a big impact. So it's all about sort of short-term pain initially, and then you get long-term gain. And this is typically what always happens with novel new technologies: short-term pain, long-term gain. So what we find here, the boost to productivity comes well after important innovations, right? So when the car was invented in 1890, it took a while before it was broadly introduced across the economy. So there's quite a long delay before you see the positive effects. And the same with the personal computer in 1981. It bounced around a bit, but then we had the big productivity growth from about the mid-90s. So I think we can expect, maybe things move faster these days, but there will still be a delay. There'll be the short-term pain, and then some delay, and then we'll have the long-term gain with productivity growth. At this stage, it's difficult to say if this will be any different to the other technologies that have affected the economy over the centuries. So some people are more worried about this, that it'll have a more negative impact on jobs, but it's too early to say. We'll need to have new jobs invented. So I think before we wrap up, I just want to talk about investing in AI. So, I've mentioned several names up to now, but there are three key things, there are three building blocks in AI. You need data, right? You've got to train your models on data. You need the algorithms. These are pretty much the neural networks. So those are provided by a few players, and frankly, a lot of them are unlisted. And then you need the compute power on the right. And that'll be your semiconductor companies like NVIDIA, or your cloud providers, the hyperscalers, Amazon, Microsoft, Google, Oracle, Alibaba Cloud. So there are a couple of players there. So either you invest in the building blocks, or you just invest in the whole thing, right? Some companies over time, obviously with productivity growth, all companies, or a lot of companies will benefit from this. Not all companies, some companies will be challenged. So you need to pick now, like we saw in 1999 with the birth of the internet, most people have been investing on the compute side for now. This is where the most obvious benefits are evident right now, right? So NVIDIA and the cloud companies have done the best. NVIDIA, similar things like AMD, another GPU producer, Broadcom, a lot of the semi companies have done particularly well this year. And then the other companies, the hyperscalers, and these are those big cloud companies. So that's the rush, like we saw in 99 when people bought Cisco, even Global Crossing, Juniper Networks. So there are a lot of the plumbing sits on the compute side. In the algorithm segment, a lot of these companies are unlisted, but Alphabet is very strong in this area. Microsoft obviously has got the partnership with OpenAI, so they benefit here too. And then on the left-hand side, this is an interesting field because up to date, most of the data that's been used has been public data, right? So largely treated as free data. But the private data is going to become very important. This is where Anchor's app apps will be based on anchor data. So what we are looking at the moment are there are a lot of companies like Recursion Pharmaceuticals, which is an AI, a drug discovery business using AI. We own that in our global tech fund. And that's frankly, it's actually doubled in the last week, because I think people are realizing that their data is very useful. They've now taken an investment from NVIDIA. NVIDIA have obviously realized that they've got very interesting data that will help them discover new drugs. Snowflake is another one. Snowflake's an interesting company. We don't own it across Anchor at this stage, but it's pretty much a data warehousing business. So a lot of companies will put their data on Snowflake's data cloud. Snowflake will clean up part of the data, and then the idea is to turn that data into intelligence using generative AI and what is to come. So there are a lot of different options here. This has really been the first area, compute, to pick up the most interest to date. And I think in the anchor funds, obviously we are heavily invested in things like Microsoft, Alphabet, Amazon, less so in NVIDIA. Frankly, I think we missed much of, this NVIDIA rally this year. But we are certainly there in the hyperscalers and in the other parts of the semi-industry. We've always liked businesses like ASML, which provides equipment into the semi-industry. But I think this is the interesting area for me at the moment, is the data side, and these share prices haven't moved that much, with the exception of Recursion, because of that NVIDIA investment. Another interesting area for me is another business called Accenture, which is also drug discovery using AI. The share price has not moved the same extent as Recursion, but they, for example, are partnering with Sanofi, which have that AI app. Also trying to design new drugs for Sanofi using AI. So if we just look at the action on the S&P 500 so far this year, we've had an incredible first half. I mean, the S&P was up about 17% in the first half. And if you break it down between the AI and the sort of tech, the big tech shares, about 13% of that 17 came from a handful of companies. Some people talk about the Magnificent Seven. This is more than seven here, but if you look at the blue ones, those are the chip companies. These are this is the picks and shovels part of AI. So it's Broadcom, AMD, and particularly NVIDIA, which has that, as I mentioned, 80% share of the training market. And then all these other companies have benefited too. So the hyperscalers, the cloud companies, Microsoft, Amazon, and Alphabet. So it's very much an AI-driven story. If you look at the balance of the S&P 500, which is about 74% of the market cap, that was up 4.5%, right? So, obviously concerns about recession. We've had hikes in interest rates. So this is very much seen as a secular growth story. Will we have another AI winter before we get to the next stage of AI? That is possible. But I think the feeling from a guy like Dennis Hassabis was that we would get to artificial general intelligence in maybe the next decade, right? That's his view. So within the next decade. So let's come back then and talk about the Turing test. Well, in fact, before I do that, I just want to touch on, if we break down this grouping of AI, tech, and the rest of the S&P, Pete Little, my colleague, has done this exercise where the current PE on the AI tech segment, looking out 12 months, is about 30 times. And that's about a 50% premium to the average, from 2014 to 2019. The S&P 500, obviously, if you look at the rest, that's 75%, roughly the PE hasn't really changed, the forward PE. So, I mean, as you know, a lot of this rally this year has been driven by the excitement about AI. Obviously, things performed so poorly last year anyway, so we were likely to have a recovery in the tech shares. But it really has been pushed by this AI story. So just to wrap up then, my last 2 or 3 slides, when do we pass the Turing test, right? So I've mentioned what Demis Hassabis said, that, maybe we would get there to artificial general intelligence in about the next 10 years. An important figure in AI sort of future was as an AI futurist is a chap called Ray Kurzweil. And Ray Kurzweil used to work at Google. He's written several books on how to create he's written books on how to create a brain. The Singularity is Near. We're waiting for his next book, The Singularity is Nearer. Now, what's interesting about Ray Kurzweil, he's very well respected in this field, is because he understands compute power and where are we likely to be in the next several years to actually pass the Turing test, because you've got to have enough compute power to pass the Turing test. And his feeling is that in 2029, we would pass the Turing test. So that's maybe slightly earlier than what Demis Hassabis is saying. And then his view then is once we've got there, he would test this machine that Alan Turing would have dreamt of in the 1950s. We would test this machine over several hours, asking it a range of questions to see if it didn't hallucinate, if it displayed the sort of general knowledge that we would get from humans, wouldn't get confused. And so once we pass the Turing test, then the interesting thing is, in theory, we can then merge our brains with AI, right? So at the moment, you can buy a smartphone, which is reasonably smart on its own, but when you connect it to the internet, then it becomes particularly smart because it can draw on all these data sources from all around the world. So once you merge your brain with AI, you can upload everything onto AI. You can download, in theory, information from the internet onto your brain as well. So you can do this through your neocortex, which is the thinking part of your brain. And interestingly enough, there was a conference in France, in Paris last week, talking about this field, which is now known as neurotechnology. And there are a couple of companies that are working on rudimentary systems in this area. I mean, one of them is Neuralink, which was founded by Elon Musk and a couple of scientists. And there's another company called Onward Medical. And, it's interesting because here it's all about reading people's minds. And obviously there's going to be a lot of personal data here. So there was talk at this conference last week as, how do we protect people's thoughts? So I think that's really where I'd like to close. And I'm happy to take some questions.
Thanks so much, David. That was fantastic. And thank you for sharing and putting all the time into presenting that really wonderful story. I think just obviously before we wrap up, we've got quite a few questions coming through, and I'm going to try and select a couple of them. And Dave, we'll see if we can pick these up. I've got quite an interesting question from Gerard, and I know that you've been involved in looking at some of the cybersecurity companies that are out there. And Gerard's question is a very good question because he talks about AI and he says, obviously, with coming up with generative AI, what does that mean from a security perspective? And I suppose there's two sides to that coin. What does it mean for the potential for hackers and kind of bad actors or bad players hack systems, and how does it enhance that? And then on the other side, what does it mean for companies who are actually building cybersecurity solutions? I don't know if you have any thought on that.
Yeah, look, our cyber security expert at Anchor is James Bennett, and I mean he's been quite open within the firm and in some notes that he's written that it makes the cyber industry even more important now. So, for I think a long time, in some ways, the cyber companies were, they were never large caps. They were sort of mid caps. A lot of the big companies like Microsoft, Amazon, Alphabet, they also had sort of cyber arms to them, as did IBM. But I think the emphasis now on cyber is just going to grow. So this is one area that will not be challenged by the shift to AI. If anything, more and more money has got to go into this field. So that's the one angle. The other angle is we need to introduce some other things that limit the bad actors, that sort of control. And we've seen what happened in social media, where a lot of unintended consequences of things like Facebook. But if we're going to produce fake images of people or write essays that are not written by humans, we almost need a sort of counterfeit signal. We need to have a watermark saying this is a fake image, or this is not something that I've written. So we're going to have to introduce rules around that. And a chap like Henry Kissinger wrote a book which I think is really worth reading. The era, I think it's called The Age of AI, and this is where ex-diplomats have the sense that we need to have a sort of global compact where people decide what is right and what is not right on AI, because otherwise it can get out of hand. But the bottom line is, I think it's just very positive for the cyber companies.
Fantastic. Thanks, Dave. Another question I think closer to home is, how will AI benefit South Africa and developing economies? And will it be different in any way to how it will benefit, say, developed economies and more technologically advanced economies? Which I think is a very good question.
Yeah, look, I think the biggest impact is on knowledge workers and knowledge parts of the economy. And based on that, you'd say the advanced economies, the impact on jobs would be more negative there than economies where it's more rural, where there's a lot more manual labor. So in theory, advanced economies would have a more negative impact, certainly in the short term, than economies like the South African economy. But ultimately, there's a chap who writes, I think in the Business Day, Johan Stein, he's a sort of AI consultant, and all the banks, I think a lot of the big mining companies, they're all going to be looking at their private data and saying, what smart information, can we build a smart agent to make ourselves more productive here? Anchor will be doing that in time. So, there's going to be productivity growth, but I think fortunately, to some extent, the developing world, the negative consequences, certainly initially will be less than what we might find in the advanced economies.
All right, thanks. I think there's a question here which you may be interested in taking as well, and that is, give us your share price forecast for NVIDIA over the next couple of years.
So NVIDIA have got this advantage at the moment, right? They've worked closely with the AI industry since sort of 2012. And the sense is they've, maybe it's a 2-year lead. And at the moment, people just can't get their hands on the H100 chip, that Hopper 100 chip. There are lots of A100 chips, which is the previous generation. So they are charging $40,000 a chip. They are making hay, right? And frankly, what they're doing, but I think it shows you a little bit about their thinking. The big cloud companies are competing with them too. Amazon has built its own chip. It's not as good, clearly, as the H100. Theirs is called Inferentia. Microsoft is meant to come out with its own training chip next year. Google has its own chip too. So I think NVIDIA is not going to dominate the space forever. So I mean, that's why I don't really want to buy into the share at this level. We've only had one strong quarter, though, where they upgraded all their guidance. The share price is over, obviously, the market cap over $1 trillion. The P is probably 65 times, excluding stock-based comp. So I'm just not buying that share at the moment. Sorry, I'm not giving a prediction on the share price.
All right, thank you, David. There's a question here that I'll pick up as well. One of the questions coming in is, we're looking at some of the next kind of revolutionary changes in AI, and something that's on a lot of people's minds is quantum computing. And as we know, quantum computing works on the basis that you don't have bits, kind of 0 and 1. You have something called qubits, which are actually entangled particles. It's a bit technical, but to make it simple, a qubit doesn't have to be a 0 or a 1. It can be 0 and 1. It can be partly 0, partly 1, and effectively it gives you kind of an exponential increase in potential computing and processing power. To the best of our knowledge at this point of time, and what we see is that quantum computing will play a significant part in AI, but it's still fairly nascent. The last article I read kind of indicated that the first really effective quantum computing machine that will impact AI is kind of touted to come out in around about 2030. So it's a fairly technical field. There's a lot to get right, and certainly quantum computing has come a long way. But from an AI perspective, I think we consider it fairly nascent, and probably in the next 5 years to the next decade, we will see quantum computing have a significant effect on AI and generative AI. I'm not sure. Do you agree with that, Dave?
Yeah, I think you've answered that. So that's a good answer, Deon. Yeah, I mean, at the moment, it's just in research and development phase, quantum computing, but it allows us pretty much like Ray Kurzweil talks about, it allows this advancement in computing power to continue, is where you go from, using CPUs and then a lot more GPUs, and then you go to quantum computing and then you go to a whole new level. So the speed of processing will just continue to grow.
All right, thanks, David. We'll take another couple of questions, just two more. Just one question from an investment perspective, and bearing in mind what we've said about semiconductors, there was some kind of up and down results from TSMC, I think, yesterday, and that's Taiwan Semiconductor Manufacturing Corporation. They spoke about the potential shortage. I know they're building a plant in Arizona, I think, to try and keep up. But one of the reasons for the drop in earnings was the upcoming shortage of supplies and the ability to manufacture enough semiconductors. And perhaps some of your thoughts on that.
Yeah, so at the moment, we've got a downturn in the semiconductor industry. Obviously, the economies have slowed a bit. Last year, there was a lot of, post-COVID, there was enormous demand for semiconductors in cars, computers, smartphones. There were shortages of so many things. And then what's happened subsequent to that is the spend on a lot of those products has slowed a lot. So there's a lot of inventory in the channel, memory in the channel. There's a lot of CPUs in the channel. And so it's meant that we've had a big slowdown. So TSMC results at the moment are poor. And in theory, we are potentially reaching a bottom of a cycle. It's just a cycle. We always have cycles in that industry. And then I would think by 2025, the semiconductor industry will be sort of off to the races again, once the cycle is passed.
All right, fantastic. Thanks, Dave. And thank you to everyone for joining us. I think we're going to wrap it up now. Just so you know, we will be sending a recording of this webinar to everyone who participated. So you'll be receiving that imminently. And then if there are any questions, we have got some questions which we will respond to, some outstanding questions. But if there are any questions, further questions for David or myself or for the Anchor Group, please send that to info@anchorcapital.co.za. That's info@anchorcapital.co.za, and we'll get back to you on that. Other than that, we hope you have a fantastic weekend, and we hope you enjoyed the presentation, and we look forward to hosting you again soon. Thank you very much.